Hi everyone, for this lesson I'll show you how to use this equation y equals in parentheses x minus h squared plus k to find the vertex of a quadratic equation of the form y equals ax squared plus bx plus c. And we're going to do that using the method of completing the square. Alright, let's take a look at this example here. We have y equals 6x squared plus 6x plus 7. So what we want to do is try to make this so that it will look like the top equation here. So I would take the plus 7 and bring it to this side. So let's minus 7 to both sides. So you'll end up with y minus 7, and that's equal to x squared plus 6x plus the question mark, because what we're trying to do is complete this square here. If you recall from last time, we have to take a look at the b. In this case, the b is 6, so we have to take the b divided by 2. So in this case, it will be 6 divided by 2, and we're going to have to square it. And this will give us 6 divided by 2 is 3, 3 squared is 9. So we can actually replace the question mark with 9. So let's erase that, and let's add 9 to it. But if we add 9 to the right hand side, we also have to add 9 to the left hand side. Right? So now our equation becomes y plus 2 is equal to x squared plus 6x plus 9. Now, since the right hand side is a perfect square trinomial, we can actually transform this into a binomial squared. Right? So it would be x plus, the b over 2 was 6 over 2, so it would be plus 3. And then the left hand side is just y plus 2. Now all we have left to do is minus the 2 to both sides. So we have the minus 2 over here and minus 2 over here. So the plus 2 and minus 2 over on the left hand side, we can actually erase. So you're only left with the y. And if you look at it, this equation that we ended up with matches exactly with the equation up here. Right? So we can actually pick out the h. In this case, it's this here. Just be careful though, it's a minus h. So if this were a plus 3, h would be a minus 3. So h would be a minus 3 here. And then the k is just this number here. It's a plus k, so k in this case is a negative 2. So the vertex that we want to find for this equation will be negative 3, comma, negative 2. Now we can check to see if our answer is correct. So this is the vertex that we found, negative 3, negative 2. And this is the quadratic equation that we started off with. And if you look over here, this is the parabola of this equation on Fluid Math. And if you go look for the vertex, it is located at negative 3, negative 2. This is your x and this is your y. And so we're right. And we're happy. Alright, let's take a look at an example where the coefficient of x squared is not a 1. So if we look at this, we have a 3 for the coefficient of x squared. So what we have to do is divide everything by 3, whatever that coefficient is. Divide that by 3 and the 21 by 3. So now we end up with x squared plus 4x, and then we'll leave some room here, and that's equal to 7 on the right hand side. And we have to think of a number that we have to add to this expression that will give us the perfect square trinomial, right? And the step is to take the b and divide it by 2 and then square it. So this will give us 4 over 2, which is 2. 2 squared is 4. So we're going to add the 4 to both sides. Right? So we'll end up with x squared plus 4x plus the 4 here to the left hand side. And then we have to do the same thing to the right hand side, plus the 4 too, to keep the equation balanced. Right? Now, since this is a perfect square trinomial, we can rewrite this as a binomial squared. So the x will go here, and it was 4 over 2, so the 2 will go here. Right? 4 over 2 is 2, and that's a plus sign, and that's equal to 7 plus 4 is 11. Okay? So now we can just take the square root of both sides. So we'll end up with x plus 2 on the left, and that's equal to plus minus the square root of 11. And there's only one step left, and that is to subtract the 2 here and subtract the 2 here. We can actually erase the plus 2 and minus 2. So x is equal to plus minus the square root of 11 minus 2. So that's the those are the two values for x. And we're done. And we're happy.